All right, so here we have a problem. It says consider the following equilibrium and equilibrium constant. It gives us a balanced equation and it gives us our KEQ value. If 2 moles of H2 is mixed with 2 moles of I2 in a 0.5 liter container and they're allowed to react, what is the equilibrium concentration of HI? So it gives me enough information to find those initial concentrations for the H2 and the I2. I know that molarity is equal to moles per liter, and it's 2 moles for each of them over 0.5 liters, which gives me 4 molar. That is for the I2 and for the H2 because we have the same number of moles of each. So that allows me to fill in my initial concentration of each of my reactants. Now, initially, in terms of our product here, we know that we don't have any products when we start. Only once the reaction has begun do we have products. So we will always put a 0 for our initial concentration of the product. Then we're thinking about, well, how do these things change during the reaction? Well, we're losing reactants. Those reactants are being used up to make products, and we're gaining products. And we are also gaining and losing stoichiometrically, meaning we're looking at those coefficients in the balanced equation to determine how many of them are used and how many of them are created. So for our reactants, we are going to be losing some amount of H2, we're going to be losing some amount of I2, and we will be gaining 2x. This 2 is coming from the fact that it has a coefficient of 2 here. For our hydrogen and our iodine, those were both just 1x because the coefficient was 1. If it had been 2 or 3, we would have put that in front of the x as well. Okay, so at this point, sometimes you have enough information to solve for x, but it looks like this time we don't. So things are going to be solved with relation to x in the KEQ equation. So I read this like a statement for hydrogen, 4 minus x. That's what I have here at equilibrium. I have 4 minus x here. And then I have 0 plus 2x, which is just 2x. Now we talked about when we're filling in or when we're solving for KEQ, we're always using these equilibrium concentrations. So instead of having numbers that we can plug in, unfortunately, this time when we plug it in, it's still going to be in terms of x. All right, and I know that my KEQ is equal to the products over the reactants raised to the power of their coefficients. So I have HI, and this is squared, over the concentration of H2 and the concentration of I2. Both of those just have a single, a 1 as a power. Then you can plug in the things that you know. So I know that my KEQ is 50. So 50 is equal to, the concentration for HI is 2x. So that goes on the top, 2x squared, again, because I had a 2 on the left side. And then on the bottom, I have 4 minus x for H2, 4 minus x for I2. And so I'm actually just going to combine that on the bottom and say 4 minus x. And this is squared because there's 2 of them. So 4 minus x times 4 minus x is just 4 minus x squared. So now I just need to solve for x in my equation. In order to do that, I will need to take the square root of both sides. And then I get 2x divided by 4 minus x is equal to 7.07. So my x is equal to 3.12. And that's just using algebra there on each side and combining like terms to get there. Now, once I've solved for my x, then I'm able to go back. Remember, our goal was to find the equilibrium concentration of HI. And the equilibrium concentration of HI is 2 times X. So I have to say my final step is 2 times 3.12, which is equal to 6.24 molar. All right, let me know if you have any questions.